Good afternoon everyone, we are Group 5, and today we will be presenting on the telephony communication system. Telephony communication system is defined as a system that enables long-distance voice communication. It achieves this by converting sound, specifically our voices, into electrical or digital signals that can travel across distances. Telephony actually began back in 1876, when Alexander Graham Bell invented a device capable of converting sound into electrical signals. The word telephone itself is derived from Greek and literally translates to remote sound, which describes the device by carrying sound to a distant place. Now move on to the fundamentals of digital telephony. We have broken this down into 3 subtopics. The first one is digital voice communication. In this system, our voice, which is naturally analog, is converted into a binary stream. It allows us to send voice over long distances without losing quality. Next, the method we use to convert that analog voice into a digital signal is called pulse code modulation, PCM, in 3 fast steps, which is sampling, quantizing, and encoding. The last one is transmission over wired channels. Once our signal is digital, it needs a physical path to travel, which is where wired channels come in, specifically the twisted pair cables.
In the early days of telephony communication, voice calls were handled by the public switched telephone network, also known as PSTN. This system connects users through physical telephone lines, terminals, and central office switches. Calls are routed from one exchange to another using dedicated circuits, ensuring stable but inflexible communication. Originally, many of these connections were even established manually by operators before automatic switching systems were introduced. As technology evolved, manual and mechanical switching was replaced by electronic switching systems, also known as S. These systems use digital electronics to automatically control call setup, routing, and termination. S significantly improved reliability, speed, and scalability, forming the foundation for modern digital telecommunication networks. The next major step was ISDN, or Integrated Services Digital Network. ISDN allows voice and data to be transmitted digitally over the same network. This made it possible to connect telephones, computers, and local area networks using a unified digital infrastructure, improving both efficiency and service quality. Today, communication has largely shifted to Voice over Internet Protocol, or VoIP. In a typical setup, calls travel from devices through a router and network switch. VoIP converts voice into digital packets to send over the Internet, while PSTN uses analog electrical signals over dedicated copper lines. This difference offers flexible, low-cost, and highly scalable communication for homes and offices.
Wired telephony systems have been important in development of communication infrastructure and continue to impact various sectors today. It improved social connectivity across large distances in a reliable and affordable way, especially in rural areas where other technologies are limited. Furthermore, it is widely used in banks and large enterprises due to its reliability, stable quality, and security advantages. In this section, we'll look at the challenges and opportunities of wired telephony systems, which continue to play an important role in communication. One of the main challenges is the aging copper infrastructure, which causes signal loss, interference, and higher maintenance costs. PCM-based systems also face performance limitations due to quantization errors and sensitivity to bit errors, affecting voice quality. Additionally, wired telephony is facing competition from mobile networks and voice over IP, VoIP, which offer more flexibility and lower costs, making it harder for traditional systems to compete. Despite these challenges, there are opportunities for improvement. Fiber optic infrastructure can replace copper cables, improving transmission quality and scalability. Advances in digital signal processing, such as better voice coding and noise reduction, can further enhance system performance, making it more adaptable to changing conditions. Lastly, wired telephony remains essential in critical applications like emergency services, where reliability is paramount. In conclusion, while there are challenges, technological advancements provide significant opportunities to modernize wired telephony and ensure its continued relevance.
Let's discuss about the future outlook of wired digital telephony. When was the last time you used a landline phone? Most people don't use it much anymore, but wired telephony is still very important. In the past, these systems relied on copper-based networks, which are more affected by noise and signal loss. Today, wired telephony is evolving into fiber optic infrastructure, which uses light instead of electricity to provide faster and more reliable communication. This is why wired telephony remains essential, especially for critical services like hospitals and emergency communication. Wired telephony is still important in critical situations because it is reliable and stable. In addition, PCM-based voice encoding ensures consistent voice quality, which allows wired telephony systems to integrate smoothly with modern digital communication platforms. Looking ahead, wired digital telephony has strong future opportunities. The use of fiber optic infrastructure and advanced digital signal processing can further improve system performance. At the same time, PCM remains important because of its simplicity, reliability and predictive performance, especially in critical services, while continuing to serve as a foundation for modern digital voice system design. To conclude, wired digital telephony remains important because of its reliability and consistent performance. As George Bernard Shaw once said, "Progress is impossible without change, and those who cannot change their minds cannot change anything." This reflects how wired telephony has evolved through digital techniques such as PCM while remaining relevant in critical communication services.
Thanks for watching.